Hey everyone, Jai Shri Krishna, welcome back to my channel. So, for today's problem, I'm solving pattern number 12. It is a butterfly style pattern with integers. So, we are given an integer n and we need to recreate this pattern for any value n. And the approach that I followed was to break the problem into three parts. The first one is this left hand side's right angle triangle, then spaces, and then right hand side's right angle triangle. So for the first half printing, I have used the outer loop. This I to n is iterating for the outer loop, and then this is for the inner loop for left hand sides right angle triangle. Okay, and this is going from 0 to I, like it will be printing and I'm printing j plus 1. So it will go from 1 1 to 1 2 3 4 5 6 7. I mean, that way it will be printed. And after that I'm printing the spaces. So the formula that I figured out to print the spaces was to do 2 into spaces minus 2. So if I consider, if I is 0 and n is 4, then we need 6 spaces in between both the triangles. So to print the 6 spaces, what we can do is, if n is 4, 4 minus uh, I is 0, so it will be, the spaces will be 0 automatically. So it is like 2 into 4 minus 2, because we need 6 spaces. uh, from this formula, it is printing 2 spaces more. So I'm just simply subtracting from the product, from the output, minus 2. Okay, from the sum I'm basically subtracting minus 2. I mean, from the product that we are getting by multiplying this and this, we are subtracting minus 2 to achieve 6. So in this way, we can print the desired number of spaces between two right angle triangles. And after that, simply we need to print the second, that is mirrored right angle triangle. So to print that, we can iterate the loop from in the reverse order, from 1 from 5 to 1. If n is 5, then we can go from 5 4 3 to 1, 4 3 to 1, like that, you know. And if I is 0, like if we consider here, if I is 0, then what we can do is, we can check, uh, I mean, it will be I plus 1 here it will be I plus 1, so it will go from 1 to 1 is greater than 0. So yeah, and then it will iterate basically one time. And if I is 1, and then it will be printed like 1 0. And if I will be 2, then it will print like basically 2 then 1 and then 0. Okay, so it is basically what I'm trying to say is, to print that mirrored right angle triangle, we can iterate the loop in the reverse order. And if, like, we run this, then we can see, like, this required desired pattern is printed uh, while printing the left hand side's triangle spaces, desired number of spaces, and right hand side's triangle. And the time complexity for this is big of n square, as this outer loop is running for the column side, and inner loop is running to print the rows and everything. So it is proportional to the number of, the inner loops are proportional to n, and then the outer loop, like, there is this product, so that's why time complexity is big of n square. And then no extra spaces are required, so the space complexity is big of 1. So if we process and check, it is passed. And if we see the advanced analysis of this, if you see, yeah, big of n square, because of nested loops that runs n times, and the inner loop runs maximum of n times in total. So a maximum of n times in total inner loop is running. Okay, and the space complexity is big of 1. And this is the code analysis. The code is generally well structured, produces desired lines. So what TUF plus dashboard offers is it also provides us the suggestions. We can see, however, some variables name could be more descriptive and function to handle the space. Okay, it is just like renaming the spaces and everything, and providing us the general suggestions. We can do that too. For now, we can format the code for better readability. And in the editorial section there is this another, the it is like kind of similar formula to print the spaces, uh, the slightly different than mine. Here they have, if n is 4, then we need 6 spaces in between the triangles. So what they have done is 2 into 3, 4 minus 1, that is 3. So this is how they achieved 6 number of spaces between the two triangles. So we can go with this way as well. And rest of the things are same, like for printing each row, then for printing the spaces, and then printing for another row. So yeah, this was like the editorial section. And I like the time complexity explanation. Big of n square when n is the number of rows provided as an input. And when the big of 1 has no extra spaces being used to print the patterns. We have used the spaces plus that only takes constant amount of memory. So yeah, that is how it is big of 1. So that alright, that's it for this video. Uh, until then, if you found this explanation helpful, drop a like, share with your coding friends, and subscribe for more upcoming problems. So see you in the next one. Until then, keep coding, keep exploring, keep smiling. Toodles!